In this video, we're going to take a bit of a break from learning some new content, and we're going to have a breather and review some of the concepts that you would have seen in Year 9 and we've been practicing over the last few lessons. So in this particular example, we've got a worksheet and we're going to start out from simply plotting some points all the way, working ourselves up to using some of the content we saw in the first lesson, so distance and midpoint between 2 points, graphing lines, and build ourselves up to being able to actually graph lines from points and gradients and simply graph from an equation in slope line or slope intercept form. So jumping back up to the top, consider we've got a Cartesian plane. Got a Cartesian plane already drawn for us. Zoom it in just so we can see everything. So here's our Cartesian plane, and it's asking us on this Cartesian plane for question 1, it's asking us to plot points A and to plot points B. Now, recalling that when we're working with these points, these are called like a ordered pair, and the way in which they work is that we have an x value and we have a y value. And recall our y plane or our y axis goes vertical, and as we go up our y values increase, and our x plane or x axis is horizontal, and as we move from left to right our values of x increase. Now jumping into the plotting, consider that we have point A, which is -2 and 1, and we want to plot it on this Cartesian plane. Well, what I'm first going to do is look for -2 on the x-axis, which is here, and then I'm going to look at 1 on the y-axis, which is just here. So we've got this point here, which is A, and we call it -2 and 1. Now the second point we need to plot is B, which is at x equals 4 and y equals 4. So going across the x-axis to 4 and then going up on the y-axis to 4, we have our point here. So I'm going to label that B, which is 0.44. Now going down to question 2, it's telling us draw the line that passes through points A and B. So notice I don't have a ruler on my laptop, but what I do have is shapes. So I'm going to draw a line that passes through both of these points here. So I have to make sure that it passes through both points, and it's not going to stop. It's going to go all the way to each end of this Cartesian plane. And the reason it does that is because we're drawing a line, and when we draw a line in mathematics like this, it neither has an end nor a finish. So we draw the line and then we put some arrowheads on it, and the arrowheads denote that the line has neither a start nor a finish. So question 2, draw the line that passes through both points A and B. That has been done. Now clearly label the x and the y intercepts. So recall back, what did we say the y-intercept was? Well, a little hint here is the points where the line cuts the y-axis and the x-axis. So our y-intercept, if we look at where we cut the y-axis is here, and that is 0.02. So this is the y-intercept. And the x-intercept, well, that is the point at which this line crosses the x-axis, and you can see it crosses here at -4. So we can say that it is -4, and notice that the y value is 0 here, and this is the x-intercept. Going onwards, so we've labeled our intercepts. Now it's asking what is the gradient m of the line. So remember, gradient is denoted by this symbol here, m. And remember, it is the gradient, m, is the rise over the run. So let's use the points where we intercept the y-axis, because firstly, actually no, we won't use these points. We'll use the original points we started with, so A and B. And the reason we're going to use these points is, notice that they're both whole numbers. So they cut through the grid at exactly so notice the grid itself. They cut where the grid meets. So it's not half a grid line, it's not a third of a grid line, it's exactly at point -2 on 1 and 4 on 4. So if we draw, say, if we go upwards and then we go acrosswards, we get this nice triangle. And what we're going to say is, well, what is the rise? Well, the rise is the amount of distance that we go up. So from here all the way up to here, this would be our rise. Now we can either count the squares and go 1, 2, 3, 4, 5, 6, or we can count the amount of units that these squares represent. So we're going up, say, 1, and we're going up again, 2, and now we're going up a final time to 3. So what we have is a rise of +3. That is a horrible looking 3, so I'm going to redraw that. There we go, a slightly better looking 3. And we're going to do the exact same for going across here, this run. So what is our run? Well, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 individual squares, or these individual squares stack up to 1, 2, 3, 4, 5, and 6. So we've got a run of 6. Now going back down, what did we say our gradient was? We said the gradient was the rise over the run. So going back out, the rise over the run, so we had a rise of 3. So I'll put that in, 3. Then we had a run of 6. So a run of 6. So therefore, our gradient equals 3 over 6, or we can say 1 over 2. So half. We've got a gradient of half, or 0.5. Now the next question, question 5, it says state the equation of the line. So recall the equation of a line is this guy here. So it's y equals mx plus c. And remember, the c, that is representative of the gradient, which we saw here. And notice we've already done the gradient. It was the rise over the run, and we found that our m was either half or 0.5. So what we can input here is that y equals either half x plus c. Now, this other variable, what is c? Well, recall that when, say for example, x equals 0, what would y equal? So if x is 0, then we're only going to be left with the c value here. So the question at hand is, what is our y-intercept? So our c value is this guy here. Value of c. So what is our value of c in this case? Well, our value of c is going to be 2. So let's just say c equals 2. So the equation of our line is going to be y equals either half x or 0.5 x plus 2. So I have a situation of how you'd like to represent this is permissible. Either you can do the gradient as a fraction or you can do it as a decimal. It doesn't really matter. I'd recommend picking whatever form is the most precise. So if you can't simplify the fraction and it turns into an irrational number, then use a fraction, but otherwise you can use either. It doesn't really matter. But this is how we would do or state the equation of a line for this particular line here. Now moving onwards, we're moving into some more difficult territory. So recall the distance and midpoint formula. It's asking us to find the distance and the midpoint between points A and point B. And remember, the distance is say from here to here. So the distance itself is the length of this green highlighting. So to do that, we've got this formula, the distance formula, and it's simply a matter of substituting in the values. So if we say that this is point 1, and this guy here is 0.2, then we can write, so x2 is going to be this guy here because it's 0.2 and that's our x value. So 4 minus, and then 0.1 is this -2. 4 minus -2 squared plus y2, so this guy, also 4 minus 1, and that is all squared, and that is all square rooted. Now notice what's going on here. Well, this is a little bit funky. We've got a minus negative. What does a minus negative turn into? It turns into a positive. So that's going to be 4 plus 2. And 4 minus 1, well, that's simply going to be 4 minus 1. So leave it that. Then we'll evaluate these individual expressions in the next line. So 6 squared plus 3 squared. Solving, we have 6 squared. So don't be fooled in thinking it's 12 because it's 6 times 6, not 6 times 2. So 6 squared is 36 plus 9. And that's going to evaluate out to roughly 36 plus 9, that is 45. Now you could, if you wanted to, you can put this in your calculator and you can say root 45, what does that equal? Well, it equals roughly 6.7. But if you really wanted to, you can just leave it in this form because what we're looking is the distance. If you can't easily deal with this square rooted number, just leave it like this. This one is less accurate where this one is precise. So that is how we do the distance going down. If we want to do the midpoint, then we're simply going to use this formula here. Now remember, the midpoint represents the midway point or the halfway point in this green highlighted line, which is roughly there. So this would be midpoint. Bingo. So to calculate the midpoint, we're going to simply substitute these values in once again, and notice we're adding the two x values together and adding the two y values together, and then we divide both of them by 2. So again, this might look familiar, as in we're taking the average of 2 points. So to do that, x1 plus x2, so it's going to be -2 plus 4 all over 2. Fix up that 4. Done. And then 1 plus 5 divided by 2. Evaluating these expressions, we get 2 over 2. So 2 or minus 2 plus 4, or 4 minus 2 is 2. And then we're going to get 6 over 2. Evaluating again, we get points 1 and 3. So do we think this is our midpoint? Well, if we want to check, we can go up and we can graph 1 and 3 on the particular graph here. So we'll find x equals 1, then go up 1, 2, 3, it is roughly, is that right? 1, 2, 3. Definitely doesn't look right. So let's go back. Where did we go wrong? Here's where we went wrong. I substituted in the wrong value. So that's not 5. That's not 3. That should be 4. And this should be 5. And therefore this should be 2.5. Good thing I checked. So going back up, we want to look for x. So x equals 1. Okay, x equals 1 and y value. There we go. That's neater. X and y. So x equals 1, y equals 2.5. Let's go back up. And we'll go x equals 1. So here. And y equals 2.5. It's roughly there. So I'll get rid of the previous one. That's not right. And then I'll put it in. So 1, 2.5. And indeed, this is our midpoint. Much better. Now, going onwards, question 7. A line passes through point 02 and has a gradient of m equals 2. Draw the line on the graph. So notice I've got two different pieces of information. It passes through point 02 and m equals 2. So it's similar to the first question, but slightly different in rather than giving us a second point, it just gives us the gradient. But we can still do this. So simply graphing, or let's start by, we will find the location of 0, 2 on our axis, and we'll go, remember going on the x we'll go to 0, and then on the y we'll go up to 2, which is here, and this is point 0, 2. And then it's telling us that it's got a gradient of 2. So remember that gradient. So gradient, go m equals 2. We'll just partition that off. We can rewrite that as 2 over 1, which is the same as going here. So the rise over the run. So if we've got a gradient of 2 over 1, then it means we have to go up 2, we have to rise 2, then we have to run across 1. So this is going to be a run of 1. This is going to be a rise of 2. So our second point is going to lie here. And because I know we've gone up 2, or I should say, because we've gone across 1, we can simply go 0 plus 1 equals 1. And then we can go 2 plus 2 equals 4. So we are at point 1, 4. Now, it tells us draw the line on the graph below. So we have to draw a line that passes through both these points. I'm going to go get to my shapes. I will get my lovely line tool, and I'll make it such that it passes through both points. Notice I'm making sure that I've got my arrowheads. If I don't have the arrowheads, I'll be in a bit of bother. So I just move that down there. And that seems to be pretty close enough. There we go. Close enough. Now coloring it in, changing the white so it's nice and visible. Perfect. So what we've done here in Q7, we've got a line that passes through point 02 and it's got a gradient of m equals 2. Now the next part, or the next question goes, graph the equations below on the line above, clearly labeling the intercepts. Graph the equations below on the line above. Alright, so that doesn't make any sense. graph the equations below on the plane also below. There we go. That's a little bit better. So notice we've been asked to graph something in a different form as well, but remember it's not completely foreign to us because in the first question we were able to derive this equation from the line that we had drawn here. So what we can actually do is we can derive the line or draw the line based on this equation, and the way we can do that is by looking at a few key features. So notice we've got this bit, we've got this bit here. So what that bit is the C value, and this bit here, that is our M value. Now jumping back into my drawing tools, we can see that, there we go, get my orange. This value here, it is equal to C. So remember the equation of a line, y equals mx plus c. This value here represents C. And what that means is that the C value is the location at which we cut the y-axis. So if we go to negative 0.5, so C equals negative 0.5, we have to look for the point 0, negative 0.5. And that's going to be, I believe, here. So this is 0, negative 0.5. And this is going to be the first point we have. Now we have to derive another point, and notice now that we've plotted this point here, the y-intercept, it's simply the simple process or the same process as use Q7 because we've got over here, we've got our gradient already set out for us. So this guy here, it's as simple as saying m equals negative 0.5, and to transfer that into a fraction we can go negative 0.5 over 1, and if we want to get rid of the top, the decimal on the top, we want to turn it into an integer, so we'll multiply both top and the bottom by 2. And what this will do is we'll get negative 1 over 2. So we've got a rise and a run. So a rise, and a run. So doing the rise and the run from this point, we have to rise negative 1. So rather than going up, because it's negative, we have to go downwards. And then we have to go on the run. So because we're positive or positive 2, we're going to go to the right. So 2, 1, 2. Done. So we've got a run of 2. And then we've got a rise. Doesn't like me drawing S's. Rise of negative 1. So our second point is there. Perfect. So that point is going to be, it is at x equals 2, and it is at y equals negative 1.5. So once again, let's graph this because we've got 2 points. We can put a line that goes through both of the points. So I'll drop that guy there, and I'll put this guy straight through here. And making sure that it passes through all the points. Alright, done. Now going back, we'll fill in this line so it's nice and neat. And we won't make it purple, let's make it orange. That's a nice color. And we haven't used it before. And then we'll fit in the weighting. And thus, now we have graphed this particular line here. And if I really want to be succinct, or if I really want to be pedantic, what I can do is I can write on that line, I can write, if Word will let me, I can write, there we go, I can write y equals negative 0.5 minus, whoops, not minus, x minus 0.5. So a little bit messy, but it's alright because this is just an example of all of the processes that we can do. In time, when we practice a little bit more, we won't have to put in all of this information, so we can leave off these boxes for rise and run, and we can leave off the calculations here, and we'll simply just have a line and our equation on top. Now the final part of the question is, where do the lines intersect? Is there a special relationship? And notice that the lines do in fact intersect each other. So intersect being the point in which they cross, and it occurs right there. And to get that value, we can see that they intersect at the x and the y. So looking on the x-axis, they go back -1. So they intersect at -1, and they intersect at y equals 0. So the lines intersect at -1 and 0. And what is the relationship? Well, the relationship is perpendicular, because notice that the lines intersect at 90 degrees. Now we haven't covered this content just yet, but in the next lesson we're going to have a look at relationships of a line, and we'll have a look at how we can prove this algebraically.